that the recordings are just useful if you have attended the class, because there are explanations or comments, right, that are not the same as watching a video on YouTube, right? So there is that, but don't worry, because all these will be available for you, okay? If you actually have to miss a class due to, you know, personal issues and stuff. Okay, so it's 3:42. I'm gonna give a couple more minutes. Again, just logging into Canvas. I'm also gonna go into WebAssign. Check if you guys have enrolled already. Okay, let's start. All right, guys, so my name is Professor Luis Juliano Victorero. All right, so that's there. As you know, we will be holding these classes live, but the expectations are the same, if not even probably more, because you're gonna have more access to online tools, you're gonna have access to recordings, you're gonna have access to a whole bunch of information in Canvas, right? Now, besides the lecture hours, which are gonna be Tuesdays and Thursdays between 3:30 and 4:45, 4:50, depending on the day, right? I'm also willing to offer office hours. Now, the office hours should be better if we plan it via appointment. However, I can also offer office hours most likely on Fridays, but it will depend, all right? Because I'm also teaching high school, and even though it's gonna be live as well for them, we are required to do quite a few things. So it might not give me enough time to do it in the morning. So most likely it's gonna be in the evenings or even after class, okay? So for today's class, I just want to introduce the syllabus, the Canvas site that you probably already saw, the WebAssign, of course, the syllabus, the information that you have in Canvas, and where you can find the videos for this. All right. Are there any questions that you want me to address before I go into sharing the content in Canvas? Anybody? Can you hear me very clearly?
Yes, I can.
Okay, excellent. All right, so let's share the content. Can you see what I'm sharing right now? It should show you the it should show you the Canvas site. Can you see it?
Yes.
Yes. All right. So the home page will give you the modules, my information, where I believe I posted a video already. Yeah, there it is. And my email and how we're going to be doing the lecture, which is going to be via WebEx. That's good. In the syllabus, it will give you the amount of credit hours that we're going to be covering per week, the text, right, the textbook, the objectives. It's an introductory course in physics. So today we're going to start actually at the end with a metric system, units and units conversions, maybe vectors, we'll see. So that means that whatever is in homework 1 won't be covered today. But you also have the lecture slides, so you can always go ahead with the material. What we're going to be covering in physics, And this is where I want to ask you guys the main question of today. How many of you have taken physics in high school or in middle school? Have you ever done physics before?
I did.
You have?
Yes, I did.
Okay, so what is physics in your own words? What do you think we do in physics?
Mm.
Well, physics is a science, right?
Yeah.
Yeah. So what do you expect from a physics course?
I think it's the distance, study the distance, the energy, so
Okay.
many things I don't remember.
No, that's fine. That's fine. Yeah, I mean, we study different concepts. Physics is
Yeah.
the study of the ideas or the laws of the natural world. All right. So physics started back with the Greeks, right? And they call it physica in Latin or in Spanish as well. You probably know we call it physica. And the idea with physics and the idea behind it is the fact that every natural aspect that you observe, light, motion, heat, electricity, nuclear power, energy, everything has in its core a physics or a physical law. In middle school, I used to do this a couple of years ago, we used to introduce kids to physical science before biology and before chemistry. And that's because we know that to understand to understand life sciences, to understand the concept of astronomy, which by the way, I am an astronomer, or geology or every other science, they need to understand the physics behind it. And of course, the math. So a lot of this course will be more conceptual. In fact, the assignments are mostly conceptual. But because I feel like it's a small class, I'm going to try to go into the math a little bit. Now, don't be scared because it's going to be more application. And that's where the grading system will come into form. So, to go into the outline of the course, right, we have the introduction today, units, physical quantities, and then we're going to go into chapter 1, which is motion. And then we have Newton's laws, energy and conservation, matter, density, pressure, liquids, right? Temperature, gases, sound, waves, electricity and electrostatics, magnetism, waves, optics, and then possibly radioactivity and relativity. So I know some of you at least have heard about these topics, but you probably think there is a lot of concepts and math behind it. And that's true. There is a lot of math in physics. In fact, if you remember the Trojan horse or the war in Troy, right? If you imagine physics as a Trojan horse, math are the soldiers inside it, right? I think there is even a meme about that. And yeah, in physics, when we introduce physics, we have to go to the math. But the idea behind this course is mostly conceptual. So we're going to be going into the concepts, into the ideas, and a lot of the questions in the homework are going to be more conceptual. But I believe that to fully understand a concept in physics, you need to apply it in some shape or form. All right? So that's what we're going to be doing in class. That's why we're going to be using the whiteboard. Right? Now, we have assignments on WebAssign. There's going to be lectures, and there's going to be some homework problems. All right? The homework problems are going to be mainly your WebAssign. But if you have already read this part, the application, you know that there is extra credit. And the thing is that, guys, when I'm doing a lecture, try to mute your mic because I cannot do it. All right? The new system that we're using here doesn't allow us to mute. So, because I'm going to be doing some lecture, all right? Unless I ask you to participate, try to mute it or to keep it very low, all right? Especially if you have background noise. Now, even though we're doing online/live classes,
Sorry,
I'm going to offer 10% of extra credit. And I'm going to show you where you can find that extra credit. All right. The main part of the course is going to be your web assign and your tests. Because the final exam is 20%, and the quizzes, which are going to be almost weekly, maybe not even weekly, yes, once every 2 weeks, are 15% of your grade. All right. So you have a good chance to have a very high grade, an excellent grade. That's my aim, that you guys pass with an A, but my secondary goal is that you learn. I know that having this course online allows for many of you, so is everybody hearing me right now?
Yes, I am.
Yes, so it should be fine. So, because it's online, right, there are going to be always some aspects, like, since you're not in class, and there might be technology issues, so that's why we're recording the classes, all right? With the accommodations, I'm going to be reading them in private, and I will get back to you, but all the accommodations are going to be followed. If you need extra time for a quiz or for homeworks, that's all going to be provided, okay? You guys cannot come on campus, so you guys are not going to be able to use a testing center. So the accommodations are going to be provided in private and at home, okay? So for example, if you need extra time, you will get it. The time and a half normally that some of you may need. So that's fine, okay? You don't have to worry about that. And again, the same will happen with the office hours, all right? Now, let's go into the grading system or the student evaluation. So the web assign are online assignments. So let's go into that. If you log into web assign, this is what you should see. It may look different in your window, right? But as soon as you open web assign, you will have assignment 1, 2. I already have 8 assignments here. And they already have their due dates, right? So assignment 1 is about motion, which, as I said, is probably not going to be covered today, but in the next lecture, on Tuesday, right? And then we have the other topics. Now, I make it so it's not very difficult. The assignments, for example, assignment 1 is only 7 questions, right? You can ask me in class if you have any issues, or you can always send me a question on email or via Canvas, right? If especially if there's a numerical question. Now, with numerical questions, be careful with the layout and with the input, all right? But if I see that you got the answer correct, right, you will get all the marks, all the points. It doesn't matter if at your first or second attempt it wasn't correct, because that might happen. All right.
Professor, I'm sorry.
Yes.
But the assignments are gonna be on Canvas or in this page web assignments?
The assignments are gonna be on. You can access web assign via Canvas. So how do you access this? Let me show you that now. So let's bring this window back here. Yeah. So if you go to Canvas here, you're gonna go to modules on the home page. So once you go into the syllabus, class recordings are gonna be here. Lecture slides are already here, so you already have the first 4 chapters right away. Web assign will be here. You click on here, you load on a new window, and you put your username and password. The credentials, I believe they're already in announcements. If you go here, that's your credential there, on the first announcement.
Got it. Thank you.
So you guys have access to that as of today. Okay. Any other questions about assignments or WebAssign? How many of you have used WebAssign before? Nobody, right? It's your first year. That's fine. All right. So it's like online assignments. Okay. Does everybody have access to your Cengage, to the book? If you don't have access to the book, remember that it should come with your enrollment to Union, but you also have the slides here. All right. So chapter 1 slides are here. You just need PowerPoint for that. Okay, let's go to the extra credit. So we were, so quizzes are gonna be bi-weekly most likely. Tests are the major component of the course, and there should be 3 major tests. I will say one at the end of September, one at the end of October, one at the end of November. All right. And yes, none of them are dropped. I do tend to drop the lowest quiz. I don't think I put it here, but I tend to do that. I don't drop any of the tests. All right. But you have extra credit and it's online. So it should be fine. Plus, I do reviews before each test. And it will be recorded. So you have a whole bunch of tools and advantages. All right? For the extra credit, so what is that? Each week, I'm going to be publishing what I call week 1 problems. The extra credit will be numerical problems. And they will be in a doc format. And most of them are going to be multiple choice. So they will be about the topics that we cover during the first week or 2. And there is no due date. So you can use the extra credit at any point, right? And it might be challenging, all right? But that's why it's extra credit, right? There is no due date. And you can always ask questions during class. In fact, I might actually do a couple of problems similar to this today. All right. So the problems are all numerical problems, and they are all in Canvas. So if you go to home, you just go into the week 1 problems, you solve them, and you can send them to me. I grade them, and in the grading system, so if you go to assignments, there it is, extra credit, right? So I already have the free test there, your assignments there, so everything is already organized. I'm gonna be adding more stuff, of course, more quizzes and more assignments, because there should be at least 12 web assigns. And yes, I should add that here. I will drop the 2 lowest web assigns. All right, so the 2 lowest grades are going to be dropped. In fact, let's do that here right now. There. Right, so the 2 lowest scores will be dropped from your web assigns. All right, any questions about the schedule, about the class, about the grading system? All right. One thing, by the way, so the class is supposed to start, or is always meant to start at 3:30. I teach in high school, and because we have all this online situation, we normally have an extension in our schedule. So I will try to start class between 3:30 and 3:40. All right. The latest I will start class is at 3:40. All right. But every time, if I think I'm gonna be late, like today, I will say an announcement. I don't think that will happen, but you never know, right? Sometimes parents wanna talk to us about their kids, you know, so that might take some time, but it shouldn't be an issue, all right? Besides, only 2 days a week, so I think Tuesday and Thursday should be fine. All right. Before we start, who is in the call right now? So we have, I think everybody's right now. With the recordings, I will be publishing the recordings in modules. It will be an external link. So if you require a password for the recording, it will be submitted to you in the announcements. So I will probably send you the lecture that we're having today at night, right? So every night you will receive a link with a recording, right? And the password for it. And then that way you can always go back if you miss something that we discussed there. All right? Oh yeah, by the way, for today, since we're not going to be covering motion yet, what you need to do is go into the notes. So we also took the time to do notes and videos. So many of you are going to be interested in going ahead and trying to get more understanding about any concept that we discussed in class. So there are some videos here and some simulations. Okay? So for today, we're going to be using this units. All right? How can I remove this? Like, oh, there it is. All right. Let's start. So we already talked about what is physics, right? Now, when the Greeks sort of started to be interested about the physical properties of different objects like matter, right? The first thing they actually started to observe were stars in the night sky, right? So I told you, I'm an astronomer. So one of the things that we know is that the Greeks are the ones who gave name to a few of the constellations that we can observe in the night sky, right? Like, for example, Orion, right? Or the 12 constellations of the Zodiac, right? But they noticed that there were some objects that seemed to move from time to time, like, for example, Mars or Venus. And they call them wanderers, right? Or planetary, which now we know is what it means by planets or wanderers, right? So to understand how a planet moves, we need to have a way to measure the motion, measure the time. So that's where the core of every science lies, especially physics and chemistry. But specifically for physics, as you can see in your screen, we need to be comfortable with the unit system. So I want to ask everybody a question. When I ask you about your height, how tall are you? In what system do you measure your height? Or how do you answer that question? Anybody, by the way, can participate. So what unit system do you guys use normally? You use the imperial system, right? The English system. So you can say I am 6 feet and a half, or just say 6.5 feet. Right? However, if you go overseas, you go to Canada, they won't understand what you're saying. I mean, they will have to convert it and they will know that's approximately 1 meter and 84 centimeters, right? So 184 centimeters. So even though you are using this system and you use it in everyday life, right? The units that we're going to be using in physics are the metric system. So we're going to be using the metric system. And there is a question in the assignment which asks you, why do we use the metric system? All right? I don't think you can see that. Can you see what I wrote on the board there or not?
No.
All right. This camera. Let's put it here. I think it's because I'm not very tall and it's following. Can you see it now? Can you see that now?
Yes.
Yes? Okay, good. So you're going to be using the metric system. Why do we use the metric system? Because the metric system is more simple to measure things with. For example, as you see in the notes, we define the meter. 1 meter, which is equivalent to 100 centimeters. So the idea behind the metric system is to have a meter which they hide because they don't want us to be touching anything here for some reason. But anyway, I'll bring it one on Tuesday. So you have a meter, a ruler, and you divide it 100 equal parts. Each part is a centimeter. You have it there on the slide anyway. All right? So that's very useful. All right? But we can go even further and introduce the millimeter. So if you have a ruler, and everybody should have a ruler for the lab anyway, all right? But if you have a ruler, you will see that between centimeter and centimeter, there are 10 divisions. Each division is a millimeter. So that's what we have the following. 1 centimeter equivalent to 10 millimeters. So 1 centimeter can be divided into 10 equal parts. Each part is a millimeter. And you also have that in there. So now you can see why it's easier to work with a metric system. Look, I was born in South America. You can probably tell, right? And I never worked with the inches or, how do you call the other one? Ounces or feet, right? I only work with meters, centimeters, millimeters, micrometers, and etc. So it's easy for me. For example, if I want to estimate the length of this whiteboard, I will say this is approximately 1.9 meters, almost 2 meters maybe. Yeah, right? But for people in the US, or if you were born in the US, that's hard, right? They will probably say, well, that's about how much? 4 feet, 5 feet? No, 6 feet, 7 feet. You see, it's harder for me because you need to know the conversion. The conversion here is very simple. Is there a way to convert from feet to centimeters? Yes, there is. You can always go and look in the textbook, right? But 1 feet, all right? So 1 feet is approximately 30.5 centimeters. That's why, right? Normally you can say that, and this is an approximation, but you can use this in real life anyway. You can say that 1 meter is approximately 3 feet. Approximately. All right? That's why in the imperial system, as you see in the notes, you also have the concept of yards. A football field, I think it's approximately 100 yards, right? Well, that's half of a football field. No, a football field is 100 yards. So normally, that can be said, or that can be assumed to be almost 100 meters, because 1 yard is exactly 3 feet. So using this and this, we can approximate a meter to be approximately 1 yard. All right, it's not exactly the same because of this. All right, but that's how you go from imperial to SI to metric system. All right, and the metric system, right, is based all in powers of 10. Okay, so let's go into the powers of 10. Right? So how many of you have heard about 1 kilometer? Again, if you remember this, right, you will know what's the meaning of a kilo, or then when we want to talk about mega, or milli, or micro, right? But a kilometer, right, is exactly, or it can be written as 1 km, which is equivalent to 1,000 meters. So a kilo is 1,000, is the power of 3, 10 to a power of 3. So this is basically 10 to the 7. All right. What about a centimeter? Right? A centimeter will be 10 squared, 100. So 1 centimeter is 100, right? Will be the power of 2. All right. But the most common one is the kilogram. All right. That's the one that you're gonna be using a lot in this course. Now, also we have the following table. So let's share this now again. See, in the table here, you have the following quantities and what units we're going to be using, which are the standard or the international standard units that we use. For time, we use seconds. However, we can also use hours or minutes, but normally we transfer everything into seconds. All right? For length, we use meters. For mass, we use the kilograms. All right? I know in daily life, you use pounds. All right? So again, you have to get used to the conversion. For example, let me see here. So 1 pound to kilograms, just for you guys to know, a pound is approximately a half a kilogram. All right? So for example, if you go to the gym and you carry 60 pounds, you can approximately say that you're carrying 30 kilograms. You are lifting 30 kilograms, right? So that's basically the conversion. For current, electricity, we use amperes. I don't think there's a difference with the imperial system there. For temperature, okay, so this is a good one. Temperature is another reason why we use the international system, the SI units. Let me share the screen, the whiteboard again. So, there. Everybody here, I'm pretty sure if I tell you what's the temperature outside, you will say, oh, right now outside, it feels like 85 degrees. Right, 85 Fahrenheit. So in the imperial system, you guys use 85 degrees Fahrenheit. I'm already used to this, so I know that this is approximately 28 degrees Celsius. Now, Celsius are the units in the international system. How do you introduce a Celsius? You make a line and you use the freeze. We're gonna do this more when we talk about temperature, but at least let me show you where Celsius comes from. All right. The freezing temperature of water is 0 degrees Celsius. You can use a thermometer and calibrate it like this, by the way. There. And then the boiling point of water is 100 degrees Celsius. Then you're probably guessing, what do we do next? Like a ruler with 100 centimeters, we make divisions here. Each division is 1 degree Celsius. All right? So each division here is 1 Celsius. All right? So that's how we calibrate a thermometer, and that's how we define the temperature scale in Celsius. Now, what happens with Fahrenheit? Fahrenheit is okay, but look what happens when you want to start doing conversions. What is the freezing point of water in Fahrenheit? Does anybody know? What's the freezing point of water in Fahrenheit? And what's the boiling point in Fahrenheit? So 0 degrees Celsius is equivalent to 32 Fahrenheit. And 100 degrees Celsius is equivalent to 212 Fahrenheit. The conversion to go from Celsius to Fahrenheit is as follows. Celsius divided by 5 equals to Fahrenheit minus 32, and I made a mistake here, it's 232. I knew it. Because that 200 divided by, this is 0.9. Like that, I believe. Now, 0.5. Let me just double check this. So that conversion is the one that you use to go from Fahrenheit to Celsius. All right? It's a linear relationship. That's fine. But as you can see, actually, this was fine. 212. If you put 212 in the equation there, you will get exactly 100 degrees here. All right? There is not really a way to divide the scale for Fahrenheit like we do with Celsius here. Right? So that's one advantage of this, of using Celsius. Okay? Just the same as why we use meters instead of feet or inches. Okay? Let's go to the table again. For chemistry, the amount of matter, we use moles. For light intensity, we use candelas. That's fine, you don't need to worry about this too. And what is Kelvin? All right, so Celsius or Kelvin, any of those are actually correct. But Kelvin will be basically Celsius plus 273. All right, So let's go back here. In the case of Kelvin, Kelvin is the standard unit that we use in physics and astronomy and chemistry for temperature. And Kelvin is defined as the amount of Celsius plus 273. That's how we know that the absolute zero, which is the temperature when all molecular motion stops, is equal to minus 273 Celsius. Okay? So that's how we go from Kelvin to Celsius or vice versa. All right? But for now, you only need to know that that's the unit that we use. Okay? All right. The same as we have for distances, the same happens with quantities like area, volume. So now we're going to start combining units to have rate of change, velocity, rate of change of velocity, acceleration, force, energy, area, and volume, right? And then we can go into some examples here and prefixes. So area is a multiplication of length times width. So you are basically multiplying 2 meters times 3 meters. Let's suppose you have a piece of paper, a wall, right, where the dimensions are 2 by 3 meters. That means that the area is 2 by 3, 6 meters squared. If it was the volume, you have the length, the width, and the height. 2 by 3 by 4. So 2 times 3 times 4, that will be 24. 24 meters cubed. Right? So that's the units for area, and you can see there the symbols. Meter squared, meters cubed, right? For velocity, velocity is defined, and again, we're gonna do this more in chapter 1, but just so you know, velocity is the rate of change of distance or displacement by time. So meters per second, and that's a symbol there. Acceleration is the rate of change of velocity, meters per second squared. And then momentum, don't worry about it, we'll discuss about that later. All right. And then some of the concepts that we're going to be studying. All right. The concept of force. The unit of force is Newton, right? Because he's the one who studied them and introduced them, you know, Newton's laws. Energy is joules. Power is watts. Frequency is the inverse of time, or hertz. And then volume, yes, we said volume is meter cube, but also can be liters. All right? So for volume, you have 2 standard units. It can be meters cube, which is the one that we commonly use for problems, but it can also be given to you guys in liters, right? So for example, if you guys go to the store and you want to buy a bottle of water or Coke, I believe they sell them in liters now, right? You only use gallons for fuel. So just if you know, just for you guys to know, a gallon is approximately 4 liters. All right. So there are some conversions that you need to know for daily life. All right. You don't need to memorize any of this because you will have the table with you. But just so you know, so now you can make sense of what you work in daily life. A gallon is approximately 4 liters, right? And then prefixes, right? So I already said 1,000 meters is 1 kilometer, all right? And let's go a little bit into this, all right? How we use prefixes and this. We are not going to be using probably teras, gigas. What we're going to using the most is kilo, centi, mega, right? And milli, maybe microns as well, all right? So let's go into that. Let's go into how we use prefixes. All right. But before we do that, I want to know if you have any questions about what we're introducing right now. Do you have any questions? You're good? Okay. So with the prefixes, something that is very useful that you should do is to have a small table. Remember, right? 1 kilo is 1,000 or 10 to the power of 3. Can you see that? Yes. 1 megabyte. So now you know when you have megabytes or kilobytes, 1,000 bytes, megabytes, 1,000,000. Right? These two are very important for there. You have terabytes, gigabytes, right? A gigabyte is 10 to the 9. All right, so well, that's in there. Okay. Now these are positive powers of 3. You can also have negative powers of 3. That's when you have the centi, and that's where you have the milli, micro, and nano. So let's start with the centi. 1 centi is 0.01 or 10 to the negative 2. Remember, 10 to the negative 2, right, is 1 over 10 squared, so 1 over 100. 1 milli, that's equivalent to 0.001. That's 10 to the negative 3. And then we have the micros and the nanos, right? In daily life, you probably normally get in millimeters, like I show you with a ruler. Micrometers and nanometers are mostly used sometimes in optics for microscopes, obviously, but you can also use them in quantum physics. We're going to be doing that at the end of the course. But you can also use them for describing light. Visible light comes in wavelengths of nanometers, right? So let's put here, right? 1 micron is 10 to the negative 6, and 1 nano is 10 to the negative 9. Here I want to use this space to put 1 giga. 1 gigabyte is 10 to the power of 9. Now, how do you recognize this from this? Some people make mistakes with milli and mega, for example, right? All these kilos, mega, kilo, and giga, the first letter is with capital. It's a capital letter. For centi, milli, nano, micron, the first letter is lowercase. That's how you know. All right? However, you're going to have the table with you when you need to do conversions. All right? But these are the basic prefixes that you need to know. All right? So let's work a little bit with kilos and millis. All right? And then we can work a little bit with megas, nanos, and microns. All right? If you have 243 kilograms and you want to go to grams, yeah. So you have this and you want to go to grams. You see, you have kg, that's a kilogram. So you know that a kilo is 10 to the power of 3. So you can say 243 times 10 to the 3 grams. You can leave it like that, 366, or you can leave it like that. Right? And by the way, you can just put it like this. So that's how I use my prefix. Any questions about that? Or is it good so far? Any questions?
No.
Good? All right. So that's the easy one. Let's go into centimeters to meters and then millimeters to meters. That's very important. All right. Let's go. So in the case of millimeters, right? And that's what you're going to be doing in some cases, right? I can tell you the distance a particle is moving is 12 centimeters. But I want to change it to meters, right? That's the objective. I want to change that to meters. So how do I go to meters? Well, 100 centimeters is 1 meter. So this is what you do. 12 centimeters, you say like this. You multiply by, there is 100 centimeters in 1 meter. And look what happens. You cancel centimeters, and then your answer will be 12 divided by 100, 0.12 meters. Right? So, very important. Right? Maybe some of you have already seen this before in school. If you haven't, that's fine. That's basically how you go. And actually, this will help you a lot if you want to convert time as well. All right? So we did centimeters, let's do millimeters, and then let's do conversions of time. All right? Let's do millimeters. You can be given 4,156 millimeters. And I'm going to change it first to centimeters. And then we go to meters. Right? Look. 4,150 millimeters to centimeters. What you need to remember is that 1 centimeter is equivalent to 10 millimeters. So doing like that, I write 4,156. Don't forget to write the units. And then we multiply. There is 10 millimeters in 1 centimeter divided by 10, I get 415.6 centimeters. And then, if I want to go from centimeters to meters, I will apply what I did here. Right? So now I go to meters. like that. 100 centimeters, 1 meter. I cancel, and then that will give me 4.156. Sometimes they might ask you to round this. If I want to run it to 3 sig figs, here I have 4 significant figures. All right, we will talk about significant figures. You will talk more about that in the lab. All right, but we will talk more about this next class. All right, but for now we have here 4 figures. I want to run it to 3 only, so it could be 4.16. All right, there are some examples here in the notes as well. All right, so let's do the example of 450 nanometers to meters. So how do you convert nanometers to meters? You can do it in 1 step instead of doing it in 2 steps. Here I show you how to go to here and then to meters. But we can also do right, 450 nanometers to meters. This is what you need to remember or to check. 1 meter is equivalent to 10 to the power of 9 nanometers. But you can also say that 1 nanometer, 1 nanometer is equivalent to 10 to the negative 9 meters. Can do it like that as well. Right? In fact, if you just use this, right, you have this 450 nanometers. You multiply in 1 nanometer, that is 10 to a negative 9 meters. Nanometer, and then that will give me, right, 450 times 10 to a negative 9 meters. But you see this 0? That's 450 is 45 times 10. Times 10 to a negative 9, I can rewrite this as 45 times 10 to a negative 8 meters. All right? And that will be the answer. That's the answer for that. Okay, let's go into time because it's, there is also time there conversions. Now is when using these fractions will be very useful. All right. Let's do one simple and let's do one more complicated. So we are going to convert 40 minutes to hours and then to seconds. How do you convert 40 minutes to hours? You know why this is useful? Because sometimes you get this. Sometimes you can get time equals to 1 hour and 35 minutes. And they want you to transfer or transform everything to hours. To seconds is easy. But let's check in this. Before we do this, you need to remember 1 hour gives you 60 minutes. 1 minute, 60 seconds. therefore, 1 hour is 3,600 seconds. Using that, I can change this, right? Is the camera following? Yeah. So 40 minutes, you say 60 minutes in 1 hour. And do it like that. Minutes cancel, this 0 cancel, divide by 2, divide by 2, 2/3 of an hour. This fraction is not going to be accurate. So you leave it like that. If you want to write as a decimal, it will be 0.6 with a period hours. All right? If you want to change to seconds, you will multiply this by 60, 2,400 seconds. All right? So that's basically what you have in the notes. And then there are some practice problems in there. I want to do the feet into meters before we finish today. All right? And the miles. So here, again, in the US, we use miles, feet, and inches, right? What you need to know, and actually, as I said, I wasn't born here, so I'm not used to it, but we practice, because all of us here drive, I had to remember that 1 mile is 1.6 kilometers. That's a conversion that you should all know on top of your head. And the other conversion is the feet to meters. All right, or to centimeters at least. So 1 mile is equivalent to 1.6 kilometers. I used to wonder why the distances between, if you go to a highway, are longer here than back in Canada, for example, right? When you are driving in Canada, it seems like you're going faster through every exit. That's because they use kilometers. And you see the conversion there? Anyway, so 26.2 miles. If you want to change to kilometers, you use this, right? 1 mile is 1.6 kilometers. All right, so now you can see why the metric system is better. Because the conversion between metric and imperial are not very pretty, right? So you have to use your calculator for this. So I will say 26.2 times 1.6, I get 41.92, so 41.92 kilometers. Right? So you do have this issue, right? It might not be a big deal in daily life, but in science, for example, when I know for a fact that NASA uses the international system, right? So the scientific associations or companies in the US, they have to use meters, kilometers, and all that. Why do you think? Because every other country uses that. So if you purchase something and you have a different system, there was already an issue a few years ago with a part that NASA purchased. And specifications were in different units. So millions of dollars were lost because of conversion issues. So there you are. Okay, so now, how do you go from 6 feet and 1 inch to, let's go to centimeters, and then we can go into meters. So that's the height of a person. Now, if somebody tells me that, I'm kind of like, I can probably estimate, but I need to convert it to know exactly. So remember, right? 1 feet is 0.3 meters, right? And 1 inch is 2.54 centimeters. Now from this, we know this is also approximately 30 centimeters, right? Because 0.3 meters times 100 gives you 30 centimeters. So 6 feet and 1 inch, 6 feet, 1 feet is 30 centimeters. So I get 180 centimeters plus, I have to add the inch. Inch is 2.54. So the answer is 182.54 centimeters. Very quickly, right? If you want to go from centimeters to meters, just divide by 100. So you want to go from centimeters to meters, you divide this by 100. And that will be, remember, right? The decimal goes to the left twice. 1.82. And we're going to leave the class like that. Are there any questions about what we did today? Any questions about this? So the only thing you have to go over are the notes. You can try and do the problems, the extra credit. Remember, it's extra credit. The only thing that you should do before next class is I want you to start going into the slides. So if you guys go into here, so I did all this today, right? I want you guys to go into home, and you can start looking into the slides, the first chapter. We're going to start talking about motion, all right? We'll do more conversions a little bit next class, and vectors, right? It's going to be important for motion, all right? All right, guys. Let me stop the recording. So the recording is going to be available tonight.